Thanks, and thanks again everybody for joining us here today for this webinar. Again, the title of this webinar is Getting Started with Serverless Computing Using AWS Lambda, and my name is Chris Bunz, and I'm currently a Senior Developer Advocate for Serverless at AWS. A little bit more about me. So I've been here at AWS for a little over 6 years across a couple different roles. I've spent some time as a solution architect, some time representing our DevOps products, but before all my time at Amazon, I actually was, well, I guess what you consider kind of more of a traditional systems administrator or DevOps person, as we might consider them today, or SRE. And what I've seen over the last maybe, half a dozen or so years as I've been here at AWS is this move of organizations into cloud. And more importantly, in the last couple of years, this move into this space of serverless. And so today, I spend a lot of my time talking to customers all over the globe about this awesome technology space that we're going to be spending time talking about here today. So why are we here today? This topic of serverless, again, is a very hot topic in the industry that's been growing very rapidly over the last couple of years. And we're finding organizations of all different shapes and sizes are really interested in serverless and pushing kind of the bounds and doing really interesting and exciting things with it. And so today's session is meant to be, again, a little bit more of a getting started guide, or getting started walkthrough, I should say, of understanding AWS Lambda, one of our core products in this space, how it works, how you can use it, and how you can get started using it yourself. So first, when we talk about this term serverless, as many kind of industry buzzwords and terms that are out there, this is one of those things that can be kind of used and abused by folks in different ways. And so for us here at AWS, serverless basically comes down to 4 different key things. First, that you should not have to think about any managing of servers. So no physical, no virtual, no containers. Anything that involves you thinking about an operating system or thinking about individual compute resources is something that in our mind you should not have to think about when it comes to things that are serverless. Should automatically scale with usage. So as requests come in, we're going to take those requests and process them using a serverless product and respond to them as necessary. Never have to pay for idle. So there's a number of stats that are out there in the industry that talk about how in most enterprises, most of their IT resources sit idle 80% of the time. That's quite a lot of money being spent on resources that are maybe never being used or being used very, very lightly. And in the world of serverless, you don't have to think about capacity planning in the traditional way. And obviously, we'll talk about this here throughout the session about the products that fit into this, but not having to pay for idle is one of the key really strong benefits of the serverless space. And then lastly, availability and fault tolerance being built in. So here at AWS, we have a concept of regions. We have many of those around the globe, and inside of regions are availability zones. You can think of them essentially as individual data centers that are in a geographic region, have a lot of connectivity between them, and one of the key foundational aspects of building for fault tolerance and high availability in AWS is this concept of building across multiple availability zones. And so when it comes to serverless products, this is not something that you yourself have to manually do. This is something that is going to be built into the products themselves. And so you can basically start with a foundation of having greater availability and fault tolerance without necessarily having to make some of the technology decisions yourself. And so the products I'm going to talk about here today that we consider serverless, again, meet all 4 of these criteria. And we have a lot of products at AWS that meet maybe 2 or 3 of them, but really it's kind of these 4 pillars of what serverless is that define what goes into the box of serverless and what doesn't. Now, at the center of this world for us here at AWS is a service called AWS Lambda. Now, at the end of the day, AWS Lambda is a compute service. It is built on top of servers. But again, going back to the previous slide and the talking points about not having to manage them, it absolutely applies here with Lambda. With Lambda, you're not thinking yourself about the servers, the operating system, patching and maintaining them. It's a very high-level managed service. Now, what you do think about when it comes to Lambda is the code that you write in your functions. And again, we'll be talking more about this here today. Today, we support 5 primary languages, so Node.js, Python, Java, C#, and Go. In those, we have sometimes several different versions of those that we'll support. We actually most recently just started supporting .NET 2.1. We also just recently started supporting Node.js 8. And so we'll periodically go and update these languages as well as add more languages. So this year we added Go and have updated, again, versions of these supporting languages. There's also actually a pretty interesting ecosystem of third-party companies or open source projects, I should say, that have been written to run on top of Lambda that support other languages. So just because you don't see the language that you may be developing today here, it doesn't mean that there may not be a third-party library that will support it for you. And again, we're adding to this list periodically as customers demand. Now, when we talk about a serverless application, it's made up of essentially three components. There's the event source, the function itself, and then whatever it is that the function itself might be talking to, say other databases or data stores, API endpoints, other services that might exist. Now, I won't talk so much about the third column here, but we're going to spend most of our time today talking about the event source and functions. So when it comes to event sources, we've got a little over 30 services here at AWS that can directly invoke Lambda. There's many more that can invoke it indirectly via several of the means that can directly invoke Lambda. But essentially, an event source is typically tracking something like changes in data state, requests to endpoints, or changes in some sort of resource state inside of your infrastructure, such that when a request comes in, we take that request and pass it into compute infrastructure that we manage, where we pull down your code, spin up an execution environment, pass the event and all of the things necessary to execute it into that compute environment, execute it for you, and then essentially after that, you can think of the infrastructure as not really mattering to you. And so it's a really interesting, exciting space, again, based around this world of Lambda, and that's where we're going to spend most of our time focusing today. Now, when we talk about Lambda, we talk about the code existing in what we consider a Lambda function. That's basically the unit of deployment and the model that you think about in terms of configuration. Now, a Lambda function has a couple of key aspects about it, but there's three that are directly related to the programming model for Lambda that are important. The first is this concept of a handler function. You can think of the handler as essentially the entry point into your code that exists inside of your function. And so a handler function, which we see an example of here, is basically, again, where we're going to pass in an event object and a context object. We'll talk about those here in a moment. And then this is where your business logic would exist out of. And essentially the handler function, again, is one of the core components of defining what a Lambda function is. You have to tell the service where your handler is so that we know where to pass the event into your code base. Now, the event object, much like the name sounds, is essentially the representation of whatever the event source is passing into your Lambda function. So for example, if we talk about an API, this is going to be the information passed in from, say, an API gateway service. If we were talking about AWS S3, it would be the bucket or then the object name that might get passed in. And again, depending on your invocation service, or if you're just invoking directly raw via the Lambda API, you can actually there define your own JSON structure. But essentially, again, the idea here is that it contains the bits that you need in order for your function to do something worthwhile. Then we have the context object. The context object is another aspect to your function definition and another resource available to your function that essentially allows your function to interface with the underlying infrastructure and kind of the surrounding Lambda service. So it contains a bunch of information about how your function is configured, as well as providing information around things such as the log group, the timeout, and as well as giving you the ability to kind of talk upstream to the service to say things like you failed or you've completed the work you're looking to do. And so again, these are kind of the three most basic components of a Lambda function. And again, we'll be talking a little bit more about each of these here today. When it comes to Lambda, the pricing is really unique about it. When you have a Lambda function, it is going to be a combination of the memory that you configured it for, and then you get billed in hundreds of milliseconds of time based on the memory that you configure your function for. And so basically this is one of the most finite, smallest units of compute pricing that can exist. There is no such thing as a commitment or an hourly charge or daily or monthly minimum, no per device fees. You never have to pay for idle again, one of the key components of serverless. And so essentially per invocation, billed in hundreds of milliseconds, based on the amount of memory that you configured your function for is how Lambda pricing works. Lambda is part of the free tier. So we have here at AWS a free tier that covers many of our services. And so with the free tier for Lambda, you get 1 million requests and up to 400 gigabytes per second of compute workload. And this is for every customer every month. And so if you want to play with Lambda, you can essentially play with it for free, again, depending on your invocation source and what you talk to. But this is a pretty awesome way to be able to play with this product and not have to think about what it might cost you. So some other things I'll talk here about Lambda. So I already mentioned that we have 5 primary languages that we support today. One thing that you can do with these 5 languages is bring any libraries that might be from, say, the open source world, third-party packages, other libraries that maybe you've written for your application, the same way that you would anywhere else. So for example, for Python, these could be pip packages. For Node.js, these could be NPMs. For C# and .NET, this could be NuGet packages. Essentially, all of the typical dependency libraries and tooling that you might be using can be brought and packaged into your Lambda artifact the same way. Now, there's a very simple resource model for Lambda. We essentially have one knob that you can tune, and it's the amount of memory that your function is configured for. And again, this isn't necessarily the amount of memory that your function may consume, but it basically is a high-level watermark of how much is available to it. Now, when you tune that knob for memory, one thing that comes with it is a proportional amount of CPU and networking capacity or networking throughput, I guess I would say. So as you go from 128 megabytes to 256 megabytes, you effectively double the amount of CPU and network capability that your function has. And so one very common performance tuning factor with Lambda is even if you're not using all of the memory that you've configured your function for, you might be more CPU or network bound. And so in this case, turning that knob up is going to give you potentially the resources that you need to have your function be more performant. Now, we say that Lambda has a very flexible users model, and we're going to talk about some of this here as well in a moment. You'll see that we have synchronous or asynchronous invocation models as well as poll-based models. Again, deep integration with a lot of services here at AWS. More and more teams keep adding Lambda functionality to their services. And so you'd be surprised to see, again, just how many different services there are that you can integrate Lambda into. When it comes to authorization and general security, we'd say here at AWS, the security is our #1 priority. And with Lambda, there's no difference or exception to that. Lambda has a number of deeply ingrained built-in security capabilities. We'll talk about those here in a moment, but you can be essentially ensured that you have the ability to configure your function to be incredibly secure, locked down, and secured in a way that is reasonable given your workload and use case. So a little bit more about that security model here. Essentially, you could think of a function as having effectively two security policies that are available to it. There's what a function itself can do. So for example, can my function talk to a DynamoDB database? Can my function write or get data from an S3 bucket? That is one of the policies that is involved here, and that is the execution policy. The other then is what is it, or who is it that can invoke my Lambda function? So am I going to allow an API gateway or an SNS topic to invoke my function? Am I going to allow potentially another account or an IAM user in my own account to invoke my Lambda function? And so again, basically what you're doing is you're securing down the entry point into your function and then what it is that that function can do in regards to other AWS resources that exist inside of your account. And so with this, you can get really fine-grained policies and really fine-grained controls over that flow of who can do what to your function, then what your function can do, the rest of your infrastructure, and be very, very specific based on the use case of your function in terms of what it has permission to do. Some other bits here about using Lambda. So when it comes to tooling for authoring functions, essentially whatever you're writing code in today, you could continue to use for writing Lambda functions. Again, this is just normal language written code in the languages that we support. You have to package up your Lambda function a certain way, and I'll talk a little bit more about that here a little later in the presentation. But again, if you're using Eclipse or Visual Studio, we actually have third-party plugins for those. We have an IDE at AWS now called Cloud9, which I'm going to show a little bit later here as well. And again, basically anything that you're writing code in will be perfectly fine for writing Lambda code. When it comes to monitoring and logging, we often say that monitoring and logging are first-class citizens inside of the Lambda ecosystem. And basically what that means is that for our serverless services, we've got built-in monitoring and logging through a couple of different ways. With Lambda, we have a number of metrics that we will capture by default from Lambda function execution, things like failures, duration, number of invocations, a number of different metrics that we will capture and make available for you. We also capture logging directly from your functions as well. So anything that you in your code do that is essentially a printf or an output statement in whatever language you might be using will actually get captured by the function and sent up to CloudWatch logs, such that you don't have to think about doing, say, traditional logging via some sort of other logging model or some sort of logging agent. You can just output text and it'll be captured by the Lambda function and sent to CloudWatch logs. Now again, Lambda is running on traditional EC2 computing in our world, and so you have the ability to interface with processes, threads, temp space, networking sockets if you're inside of a VPC and you want to talk to other resources on the network. All of that is possible for you. Now, one last part about Lambda, one thing that's really, really key to understand is that these functions are stateless. Essentially, these are resources that are managed by us behind the scenes. You really don't have a guarantee of how long a given function environment is going to be around or running. It's not something that we want you to think a whole lot about. That said, we will keep what are considered warmed functions around for a period of time, such that as subsequent requests come into them, we can reuse some of the resources that have been used previously. Things like network connections, global variables, any data that maybe you pulled into temp space for, say, for example, machine learning workloads, which is really common. But one thing to be really clear about is that there's no way for you to address these functions based on the underlying compute resource. For example, things like sticky sessions from a load balancer are not possible inside of Lambda. So because you have no affinity or no real kind of way to, again, address that underlying resource, you do want to think about these as being very stateless, very ephemeral, and something where it could come and it could go, and it shouldn't impact the workload. Now, this does require you to, again, think about how you develop your applications in a slightly different way, but we find that, again, this kind of is part of the benefits of Lambda as product. So I mentioned before there's a number of different execution models here for Lambda. There's, again, a number here that we think of as kind of being the primary ways of thinking about it. So we have a synchronous push-based model. In this case, we see an example where we have an Amazon API gateway, which we'll talk about here in a moment, where I have an API request that's come into the /order API URI. That's going to be mapped back to a Lambda function. So it's going to invoke that Lambda function. That Lambda function is going to do whatever I have configured and written my code for it to do, and then pass the response back up to API gateway such that it can respond to the client that invoked that API. Again, this is a synchronous model. We also have an asynchronous event-based model, and we see here examples of maybe where I'm using Amazon SNS, Simple Notification Service, Amazon S3, Simple Storage Service, where either I've put a message into a topic or I've put an object into an S3 bucket, and that's going to generate a message event request back to a Lambda function, which is going to process either the SNS message or process data about the S3 object, maybe the object itself. In this case, I'm not expecting the Lambda function to tell those services what I've done or necessarily who or what it was that put the message or the object into the bucket. Again, an asynchronous model, so it's not going to give me kind of a full loop back up to those services. And again, this is kind of one way and one pattern that a number of our services use. And then lastly, we have pull-based. In this case, it works a bit differently from the first two. For example, with services like Amazon DynamoDB Streams or Amazon Kinesis, what we actually have is a Lambda service capability that is pulling those streams, looking for changes. It then pulls the messages off of them and will invoke Lambda functions on your behalf. And so with this, you can get massive throughput with Amazon Kinesis Streams, doing near real-time data analytics without you having to manage any of the infrastructure. And so synchronous push, asynchronous event, and pull-based, again, the three major Lambda execution models. Now, one thing I do want to touch on real quick here is that we just recently announced support for SQS as an event source for Lambda functions. So Amazon Simple Queue Service, it's actually the first AWS service that ever existed, very heavily used by a lot of our customers. And so SQS supports a very similar pull-based model to Kinesis and to DynamoDB. In this case, we run a poller that pulls your queue and pulls messages off of it and passes them into a Lambda function via an invocation. Now, that Lambda function or the service then can go back to the queue and tell the queue that the messages have been processed or potentially fail and let those messages be retried based on the queue's policy. But again, what this allows you to do is have a completely managed Lambda function that is feeding off of an Amazon SQS queue for batch processing without you having to think about managing any servers whatsoever. And so really excited. This is one of the most highly requested features for Lambda. And again, as of about 2 weeks or so ago, this is now available for you to consume. So when we think about all these different capabilities of Lambda, all the different invocation sources, all the different execution models, when you put all of it together, you actually get quite a lot of things that you can do with Lambda as a compute product. We actually bucket all of this down into 6 primary use cases. Web applications, so essentially powering things like single-page apps or even more complex web applications with an API backend of some sort. There's a number of third-party tools that will actually allow you to do things like have Flask or Express type APIs running inside of Lambda. We also see this for backends for things like mobile applications, IoT devices, internal microservices inside of your own infrastructure that might be talking to other services. It's another common use case. Data processing, so again, talking about services like Kinesis Streams, which are meant for doing near real-time analytics of data in massive quantities and massive scale. There's a number of customers who have built and used frameworks that effectively do MapReduce on top of Lambda, as well as batch processing. And actually, kind of pound for pound, this is one of the largest use cases of Lambda that we have here at AWS. Chatbots is the next one. So chatbots becoming an ever important way that companies are communicating not just with their external customers, but even their own internal teams. We see a number of companies that are building chatbots for essentially internal help desk or finance teams or working with HR. And so chatbots kind of showing up all over the place in different ways. And Lambda works really well with some of the chatbot services that we have here at AWS, such as Lex and Poly. And then Amazon Alexa. So if you happen to have an Amazon Alexa capable or powered device, many Alexa skills are actually powered by Lambda. And actually the Alexa team says that Lambda is essentially the easiest and best way to host an Alexa skill. It's actually really fun to build Alexa skills. So if you do have an Alexa capable device, you can head over to the Alexa developer page, learn more about that, and be able to use what you learn here today and learning more about Lambda to back-end that skill. And lastly, IT automation. And when it comes to IT automation, there's many use cases out there. And I would say this is how a lot of our customers start to dip their toes into using Lambda. We see Lambda being used in everything from essentially policy engines to infrastructure automation, responding to either, say, development or management tools, responding to issues or failures or alarms. There's all sorts of things where Lambda plugs in really well and can provide essentially the ability for you to do small little bits of logic in reaction to some sort of event in your infrastructure. And so, again, 6 major use cases here that we see for Lambda, lots of different ways that it fills gaps in these spaces and can provide the compute platform for you. I'll talk a little bit more about some of the other products inside the serverless family that we have here at AWS. The first one I'll talk about here is Amazon API Gateway. Much like the name sounds, this is an API Gateway product. So what it allows you to do is create a unified API front end for your API services. You can, whether they be microservices or monoliths, a lot of different capabilities as part of this, such as the ability for you to do DDoS protection, throttling for the consumers of your API, many different capabilities around authentication and authorization, both between the clients and the backending service. The ability for you to actually monetize an API. So maybe your business is looking to provide an API service to your customers, and you could do things such as usage tiers, throttling, get really fine-grained logging, so you could take that logging and throw it into some sort of a billing application. And so lots of capabilities here. It really extends much further into some of the things that you can do from an architectural perspective with API Gateway. Today, API Gateway can be configured in 3 primary ways. It can be configured in what we have, what are called edge endpoints. So these are endpoints that have a Amazon CloudFront CDN distribution configured with them. So this is great for mobile applications, for consumed websites that exist out on the internet. We also have the ability for you to have regional endpoints. So these are endpoints that exist just inside of an AWS region. This is great for, say, if you have company-to-company API services that you're exposing, or say APIs that need to be exposed between your own company on the public internet. This is another great place for them. Or actually, if you want to bring your own CDN configuration that you can put in front of it. And then lastly, as of just about a month ago now, we also support the ability for you to have completely private API backends inside of your AWS VPC. And so this supports the model for you to build internal microservices and be able to have, again, a completely private API with all the capabilities of API Gateway inside of your VPC. Really powerful way for building internal microservice-based architectures. Now, behind the API Gateway, backending it, there's a number of technologies that can basically run the logic for your APIs. So we support AWS Lambda, and that's one key way for you to have, again, a completely serverless API between API Gateway itself and Lambda. There's nothing that you have to manage from a compute infrastructure standpoint with that. You can also back API Gateway with endpoints on EC2. So whether they be running actually on EC2 or Elastic Beanstalk or ECS, Elastic Container Service, or AWS Fargate, anything that's running on EC2 that has a HTTP or HTTPS endpoint exposed can be made a backend for API Gateway. You can also then expose other AWS services behind API Gateway. So for example, one thing that we commonly see is customers want to create essentially a wrapper API in front of another API for an AWS service, such as exposing outbound, say, DynamoDB or S3 or Kinesis. You can actually just put API Gateway directly in front of those services, map the APIs between them, use your own authentication and authorization off of the API Gateway service, and be able to directly interface with these services without, say, having to use an AWS credential provider or hard-coded credentials in your application. And then lastly, we support the ability for you to actually put API Gateway in front of any public HTTPS endpoint on the internet. So if you have an API Gateway inside of your own infrastructure that's provided publicly, or you have one running on, say, another cloud provider or running just kind of anywhere on the internet, you can put API Gateway in front of it. And so this is a great way for you to, again, get the benefits of API Gateway regardless of where you're running. Now, one last point to mention here again is that with API Gateway, you can also put backends that exist privately inside of your VPC behind it. So whether those be on EC2 or on Lambda, or actually you could put API Gateway in front of resources that are behind a VPN or a direct connect tunnel back to your own private infrastructure. You can also use API Gateway that way as well. So lots of, again, capabilities of API Gateway, from security to performance to the ways that you can interface with it, and a lot of things that you could definitely explore further about it than we have, unfortunately, time for today. So the last component that I'll talk about here is a product of ours called AWS Step Functions. One thing that we see people doing is inside of their Lambda functions doing a lot of orchestration. Maybe you have to talk out to other services, call your own API endpoints that live someplace else. What this can lend to is having inside of your Lambda function code kind of a lot of unnecessary orchestration code, retry and failure handling, back off and exponential, retry capabilities, decision tree logic, all sorts of things that really there's not a lot of value in you yourself writing. Another thing that we see people doing is writing Lambda functions where their functions essentially sleep for a period of time while they're waiting for work to be done by another service. And there's a number of downsides to this. One is that you pay for Lambda while it's being invoked, while it's awake as a function. So even though your function may be sleeping, waiting on something else happening, you're still paying for that time as it's an active compute resource. Another is that today Lambda functions have a maximum time limit of 5 minutes. So if you're doing some sort of chained Lambda function workflow, basically the entire workflow has a maximum timeout of the 5 minutes of that first Lambda function. So in order to do this better, and I would say smarter, you can use AWS Step Functions. So Step Functions is a workflow management service that can directly integrate with Lambda. It has a lot of capabilities for failure handling, parallel tasking, decision tree logic, all sorts of things that you can do in order to basically handle all sorts of complicated business workflows with your Lambda functions. And we see a diagram here where essentially all of these green boxes are Lambda functions. And then the service itself provides just the way that these Lambda functions are going to be invoked with, again, decision tree logic, failure handling, and so forth. And so, again, instead of having larger monolithic applications that, say, are providing lots of different capabilities or potentially sleeping and waiting for other services to be executed, you can actually build this into a much more streamlined, much more resilient model with step functions. And, again, something that we're not going to go too much in depth with here today, but that you should definitely read up more about. Great. So we've talked a little bit here about Lambda. We've talked about some more of the ecosystem, the invocation structures, the event model, security model, and a number of other things here. Where do you start? Essentially, one of the great things about Lambda today is that we have a really, really rich ecosystem of frameworks that are out there. These are tools that are provided in both by, I would say, open source communities as well as private companies that they've made these tools available, and they have a lot of capabilities. Some of them are specific to certain languages that run inside of Lambda. Some of them support multiple languages. But what each of these tools is going to do is basically help streamline what's involved in managing the underlying AWS resources and just making it that much easier for you to get started. And so the general guidance recommendation that I always make for people is start with a framework. Find one that meets the needs of what it is that you're trying to do and explore it and begin using it. A couple of examples here. So there's a framework called ClaudiaJS, as the name might say, make it seem this is a JavaScript framework. And what we see here on the right-hand side is about 5 lines of code. And then we execute a command that we see here at the bottom, Claudia create. And what this is actually going to do for us is give us a Lambda function, an API gateway, all of the IAM resources and policies configured such that the API gateway can invoke the Lambda function. It's also going to take our code and put it into that Lambda function based on the scaffolding that we've seen here. And so Claudia, again, what it will do is really simplify the code that you have to write to manage your infrastructure. Again, you're not doing anything else except writing these couple of lines of code and running a command line, and it's going to give you all of those resources pre-configured and configured the right way for you. Another example of this is a service, or a tool I should say, that came out of us here at AWS called Chalice. Now, Chalice is a Python framework. Very similar to the previous example of ClaudiaJS, we've got about 5 lines of code, a single command that we run, and this is going to, again, give us an API gateway, a Lambda function, IAM policies and resources configured properly for them. And it's just going to simplify, again, what we have to do in order to get started writing and creating a serverless application. Interesting thing about Chalice is it actually came out of a completely different team from the serverless organization. It actually came out from our SDK and CLI team that was building more and more internal tooling and was looking at an easier way to build Python-based microservices with Lambda and API Gateway. And as it grew in popularity internally, we open sourced it, and now it's a very active project, again, for Python developers. Going just a little bit deeper here into what Chalice can do, and this is, again, similar to a lot of the other frameworks, what it allows me to do is, as we see here, I've got maybe just about 20 or so lines of code. I have 4 what are considered application routes, or essentially individual APIs. And with just a couple of lines of code, I can add things like complex error handling. I can add different HTTP method support. I could also do things like add authentication authorization support. And what this is, again, going to do is really simplify the lines of code that I'm writing, simplify the interfacing with the underlying services, and just make it easier for you to get started building these types of applications on AWS. And so again, there's a whole number of frameworks out there. You can find out more about them on the AWS Amazon.com/serverless website. And in general, really strong communities, and again, where I typically recommend people spend their day one getting started. Now, if you didn't want to use one of those third-party frameworks, we do have another tool here at AWS that can help make things a bit easier for you. So I'm going to talk a little bit here about my squirrel friend here named Sam. So SAM stands for Serverless Application Model, and it does have this awesome little squirrel mascot, also named Sam, as our the official mascot of serverless here at AWS. But what SAM, or Serverless Application Model, is here again is an extension built on top of CloudFormation that provides unique capabilities for managing serverless applications. And so what is inside of SAM is a couple of special resources, again, for serverless. We have serverless functions, serverless APIs, and serverless tables. And what it does here is provide a really easier way for writing CloudFormation templates that would manage these underlying resources. Now, we actually recently, a couple months ago, open sourced the translator for this. So actually, the full stack for SAM is completely open source. We're getting awesome community contributions. And you can find out more here at github.com/AWS Lab/serverless-application-model. That's where the live documentation lives, where the translator documentation lives, where we get pull requests and issues and other great things. Now, if we were to look a little bit deeper here at what a SAM template is, basically we've got 3 kind of main things going on in this template. At the very top 2 lines here, we have our headers, and the most important one when it comes to a SAM template is the second one here, the line that starts with transform. And so transform tells CloudFormation that this is a special type of template that it needs to treat differently than just a normal CloudFormation template. And what it's going to do, as the name might sound, is transform this template into a regular CloudFormation template for us. We then have a resources section, and then inside of this resources section, we have 2 different AWS serverless resources. We have an AWS serverless function and an AWS serverless simple table. Now, the simple table all the way at the bottom, what that's going to do is create a DynamoDB table with a base set of 5 read and write units. Again, just 2 lines of code there to create that for us. And then if we look here at this serverless function, what we have is a couple of lines that are related to configuring a Lambda function. The code URI, where the handler lives, again, where we're going to inject our event and context into our code. The runtime, or the language that we're using for our function. The policy, so again, here the execution policy. And then we have an event structure. And we see that this event structure has a type of API and then some properties for an API. And so what these roughly about 20 or so lines of code are going to do for us is give us a Lambda function, an API gateway, the resource policies and IAM that we need to configure this function, this API gateway, together the right way. It's going to create a DynamoDB table for us. And it's going to, again, take our code from the code URI mentioned here and configure our function for it. Now, if we were to write this into raw CloudFormation, this would actually be about 80 lines of code. So streamlining it down to 20 lines of code is a really, really great simplification. And there's a whole lot of capabilities that exist in SAM. And we've got a number of other webinars and resources online that you could find that go much deeper into some of those advanced capabilities. Another way to think about SAM here is that if we take a look at this example from one of these samples that we have up in GitHub, is that roughly from lines 10 to 25, about 15 lines of code, is actually going to generate for us 7 different AWS resources. And so the screenshot that you see here on the right-hand side is actually from the CloudFormation Designer which allows you to visualize what happens from a template. And so again, about 15 lines of code is going to give us 7 AWS resources. Much, much easier, much less code than writing raw CloudFormation or doing this ourselves in the console. Now, one of the things about SAM is that it's not going to generate your code for you like those other third-party frameworks might. And so what this means is if you have a certain confidence or a certain way in writing code and you don't want to use a third-party framework, or maybe you don't want to have to concern yourself with programming within a certain way or a certain model, SAM basically has no influence over your code, the language you use, the packages you use. It's really much more about managing the AWS resources. And actually, a number of the third-party frameworks can generate SAM templates for you, which can be really powerful into playing with the rest of the SAM ecosystem, which I'm going to talk about here today. So one of the core components that we also have as part of SAM is something that's now called the SAM CLI. We first launched it a little over a year ago. We called it SAM Local, but now, as of May 8th, it's just called SAM CLI. What the SAM CLI allows you to do is a number of capabilities around getting started with building Lambda functions, validating and testing Lambda functions, and deploying and managing them. And actually, it's pretty exciting, all the capabilities that we have here, and I'm going to demo this here in a little bit. So what SAM CLI allows you to do is it will take your application code, it will look at the SAM template inside of your local repository. It allows you to basically take that code, bundle it up into a local running Docker container, which can then allow you to execute that function locally on your laptop or workstation, wherever you're writing code, such that you can do local debugging and testing without having to put it up into the Lambda service. And so this can really simplify and streamline the process of creating and interfacing and debugging serverless applications. You can directly package and deploy from SAM, and again, it just makes life much easier. In terms of the Docker environment that it executes locally on your workstation, this allows you to basically emulate a lot of the core components and features of the Lambda runtime environment, again, locally where you're running. You can find out a lot more about SAM CLI in github.com/AWS/AWS-SAM-CLI. This is another open source project in this space, and we get a lot of really awesome community contributions and really strong community and interfacing around this product. So just a little bit more here about SAM CLI. This is just kind of a base example of what's possible with it. And today, SAM CLI has just a couple of key commands. It has an init command, a package, the local testing and execution function. It can validate a SAM template, and then it can help you deploy your application. Now, what's really awesome about the init command is it actually allows you to create a blank, brand new boilerplate Lambda function. And so if you're just getting started here with Lambda and you want to see kind of what a best practices Lambda application looks like, the SAM init capability will allow you to do that. And so I'm going to actually show this here real quickly to you so you can see how you get started with it. As part of this, I'm going to use AWS Cloud9. So AWS Cloud9 is a managed IDE. Basically, it's a cloud-hosted IDE, has a ton of capabilities in it, from code completion, from the ability to do debugging, to doing error checking, all sorts of cool stuff you can do with it. It also has SAM Local built directly into it. So in this screenshot here, we actually see a Lambda function, and then on the right-hand side here, we see my Lambda function being executed locally. And so, again, lots of capabilities here that we can dive into. So with that, I'm just going to switch over to my console and show you this. So again, this is inside of my Cloud9 IDE environment, and I'm starting with a mostly blank environment. This is an environment that I've pre-configured. I've set up the colors and such here as I like to develop. Now, Cloud9 runs on an EC2 instance, and so I have the full capabilities of the terminal here, behind the scenes. Again, I've got SAM installed, and I'm using the latest version of SAM, which is 0.4.0. I can see, again, the capabilities that I have here in SAM based on the screenshot that I showed before. And with SAM, it actually has really in detail help information. So I could say SAM init-help, and it's going to give me all the information about what is required in creating and writing or running this command. So for example, here I could see that I could do SAM init runtime Python 3.6. And so let's execute that. Great. So what it's done here, and maybe a little hard to see, is it's created a new directory for me called sam-app. And inside of this, there are a number of directories. There is a function directory called hello world, and then I've got some of the other capabilities that I would need in order for managing a Python-based function, such as the requirements.txt. I have my SAM template, which we're going to open up here real quick. Really quick here, so one of the core capabilities or one of the benefits of Cloud9, I should say, is that it has a GUI editor for SAM templates. So it can actually make it really easy for you to come in here, select the memory configuration for your function, select the execution policy that you're going to use, the role, handler, description, number of other capabilities. I'm actually just going to turn on the text-based editor though real quick. And so I can see my full function SAM template here. Again, this is the one that was created from the SAM init command. I can also open up my app.py file, so my Python file, and I see here the generated code that came with it, pre-configured and made available for me. I also see a whole bunch of things like tests and other kind of good, again, general best practices guidance that we would apply here for a Python-based Lambda function. Now I could go and execute this locally. There's two different ways that I can do that. In the resources tab here, I see that I've got a number of different functions running, and actually it's highlighting some other ones that I've put into a temp directory here. And so I can actually go and dive in here and find the function and go and say run and run this both locally or execute the API gateway that's in front of it. One of the other really cool benefits here at Cloud9 is that I can actually find all of my other Lambda functions that exist in this region, and I can pull them into this Cloud9 environment and test them further. Just real quick again in terms of SAM. So again, a number of things that I can do. So let's actually go into the SAM app directory, and I can do a validate of my template. And so it tells me that my template is valid. I can also do a local test of my function if I wanted to. So let me show you the local command here. So I could do SAM local start API and then pass the template file. And again, it's going to wrap all this up in a Docker container and execute it for me. I can also do a generate event. So I mentioned before that there are a number of different ways that you can invoke Lambda functions. And so, oh, sorry about that. I missed the key command word in front of it. So I can see here that I can generate event syntax for a number of different services. And this will actually go and give me the JSON that would be passed in. So let's say DynamoDB. And again, this is going to give me the full demo JSON that would have been passed in from a DynamoDB stream execution. And you can pipe this into your function and execute it and test it that way. So again, SAM as a command line tool is going to give you a number of capabilities for getting started. Again, I could package and deploy directly from here. I can create a completely brand new application for learning. And so a really great tool for testing and exploring in Lambda. So let's talk a little bit more about some of the other capabilities that are part of the ecosystem here. So one thing I'm going to talk about here is monitoring, logging, and debugging of your applications. And one thing I like to always say to customers is that you really can't move fast if you can't measure what's going on. And this is really key to application development and the operability of your applications. So again, built into Lambda and API Gateway, we like to say that metrics and logging are universal, right? Currently for Lambda, we capture 7 different metrics. So invocation count, invocation duration, invocation errors, throttled invocations, something called iterator age, and this ties into the poll-based models. Dead letter queue errors, we'll talk a little bit more about that here today, I believe. And then the concurrency of this function. One other thing you could do with CloudWatch metrics is inside of your Lambda code, you can actually directly invoke the put metric data API call for CloudWatch and generate metrics just based on business logic inside of your function. Then for API Gateway, we also capture 7 metrics, API calls count, latency, 400 errors, 500 errors, integration latency, cache hit counts, cache miss counts. And then inside of CloudWatch, you can actually then pull out things like averages and percentiles for those. Again, very detailed information. And so this is kind of an example here of those metrics that are available in the console today. We see in the top left here the screenshot for the Lambda console. And in the bottom right here, we see a screenshot from the API Gateway console. But we can go further than that. So again, we've got logging built directly into the platform. And so API Gateway provides a couple of different ways of capturing and storing logs. There's 2 different levels for logging, error and info. You can optionally also log the full body of a request. Now, one thing you do want to be cautious about that is if you have a high traffic application, this could generate quite a lot of logs, and you do pay for CloudWatch log storage, so you do want to be kind of cognizant of how much logging you are writing. And you could put this at a per stage or a per method level inside of API Gateway. Again, with Lambda logging, we capture some basic information per invocation, but then anything that looks like the equivalent of a console.log or printf statement for your language of choice is going to be captured and sent to CloudWatch logs. And now once you've generated these logs, there's a couple other things that you can do with them. So one is in CloudWatch logs, we have a capability called log pivots, and this actually allows you to take log information and look for data or basically regex information inside of that log line that will allow you to generate a metric. And so you could take a log line, generate a metric, and then do things like have alarms based on that metric inside of CloudWatch. Another thing you can do is you can actually directly export those CloudWatch logs from that service to things like Elasticache or S3, such that you could explore them further with interfaces such as Kibana, or use a combination of, say, Amazon Athena or QuickSight to do further kind of BI or log spelunking as it might be on that information. So lots of capabilities, lots of ways here of finding out more about your functions. And so what you can do when you put all this together is you can actually build really awesome custom dashboards inside of CloudWatch today. We see here a really basic dashboard for a serverless application where I've got information about the Lambda function, I've got information about the API gateway, I've got things like an alarm that I'm tracking, and so I could do much more than this, but again, it's really easy to throw this together and get a lot of visual information about your serverless application, how it's performing. Now, one other component that is really key to debugging and troubleshooting applications is a service called AWS X-Ray. And so what AWS X-Ray allows you to do is to essentially capture information about the calls and execution inside of your code base. We've got pretty deep integration in with Lambda for this. Basically, there's two things you have to do. You have to enable tracing for your function, and we see here there's a checkbox for that. It also requires appropriate amount of IAM permissions being given to your function. And then inside of your code, you can optionally then include the X-Ray SDK, and there's a couple different components to that. And then that allows you to wrap other things such as the AWS SDK, any sort of HTTP or HBS calls to MySQL or Postgres databases. And what X-Ray is going to capture is really detailed information about those calls, if there's any errors, if there's any warnings or failures generated, the timing, the requests frequency, and allows you to get things like the really kind of awesome service diagram that you see here, where we see visualizations of how clients are entering our application, the various components of our application, potential successes or failures, which are shown here by the different colors on those circles. One other thing that we can do is actually see a waterfall diagram of the flow of our application. And so this can be really useful for troubleshooting maybe what might be slow components inside of your infrastructure, and identifying, again, where your function is spending most of its time executing. And so turning on enabling X-Ray is one of those things that I always recommend for customers when they're trying to troubleshoot or performance tune their Lambda functions. So again, how do you figure out what's wrong with a Lambda function? Step one, turn on X-Ray. It's really powerful. It's going to collect a whole lot of information. It's going to give you a lot of visibility into your function handling. And again, as a more or less serverless service itself, doesn't require any infrastructure for you to manage. You just pay for what you consume from the service. Don't underestimate the power of logging inside of Lambda. So, the kind of simple, cheesy, debug, in this part of my code type statements work really great and can be captured by CloudWatch logs. And that's another place where I'll tell customers, well, let's just try turning on some more logging about what's happening inside of this function. And related to this is that when you're trying to understand what's going on inside of a function, some of the most powerful metrics that you can get are things related around the business logic of your function. How many records are you processing from Kinesis or from SQS? What happened in terms of API calls that are made from your function? Are you able to log success or failure there? Basically, taking that log data, potentially turning it into metrics, alarming based on that is really how you want to think about trying to troubleshoot and tool around any sort of operation issues that you might have for your function. So one last bit here I want to talk about is we have another component of the serverless ecosystem here called the AWS Serverless Application Repository. This is a place where people of all different shapes and sizes from both companies and open source projects have submitted Lambda functions, essentially whole serverless applications. You can go and find these functions and then run them inside of your account. So today these are all free serverless applications that exist. In order to post a serverless application, you have to have your function represented by a SAM template. So these do play in very closely with the SAM kind of ecosystem of tools. But this is a really great way for you to learn from other people, out there that are building serverless applications, see best practices, understand how to think about various logic, how to use SAM, how to use all sorts of aspects of the serverless application portfolio across, again, all sorts of different use cases, all sorts of different invocation models. There's a couple hundred applications in this today. It keeps growing. And so check out the Serverless Application Repository as a great way to get started. Almost everything that I've talked about here today can be found on AWS at amazon.com/serverless. This is our home for serverless information. You'll see kind of here and the middle menu bar here, there's a link to the AWS Serverless Application Repository, a link to our developer tools, including information about the third-party frameworks that I talked about earlier. Resources such as links to webinars such as this, customer case studies, white papers, getting started tutorials and links. A whole lot of information exists off of that. You can also find partners, both partners that are building technology that integrates with or on top of Lambda, as well as consulting partners that can help your business build and deploy serverless applications and get you over that initial hump of learning more about Lambda. So a whole lot of stuff there. Again, you can find so much more information than we were able to cover here today on AWS at amazon.com/serverless. Again, my name is Chris Munns. You can find me at munns@amazon.com or at Chris Munns on Twitter. Appreciate you coming here to today's webinar. Appreciate all of the questions you've been asking here. A huge thanks to my team that's been helping to cover those questions here today. And we look forward to talking to you soon on the next webinar. Again, thanks for coming. I hope you learned something, and we'll hopefully see you here again real soon.